Hello, my name is Aaron Bullman, and I will be an instructor for this lecture. I'm currently a postdoctoral fellow in the Carolina Health Informatics program and conduct research focused on using machine learning to improve medication adherence. In this video, we will talk about feature selection. So what is feature selection? Feature selection is the process of selecting a subset of relevant variables for a machine learning model. Today we will be discussing the three main types of feature selection methods, which include filter methods, wrapper methods, and embedded methods. Filter methods look at the relationship between the outcome variable and the predictor variable. When selecting a filter method, it is important to consider the data type of the variables being investigated. Pearson correlation is an option for looking at the relationship between two numeric variables. Chi-square, on the other hand, is an option for investigating the relationship between two categorical variables. When using a filter method, it is important to also consider the relationship between predictor variables. Ideally, you want predictor variables that are not very related to one another, but have a strong relationship with the outcome variable. This is a visualization of a Pearson correlation matrix created using a diabetes dataset. A correlation matrix shows the correlation between every variable within a data frame. A correlation coefficient of 1 is the most related two variables can be. In this example, positive correlations are shown in blue and negative correlations are shown in red. A positive correlation means that the two variables go in the same direction. So if one variable increases, then the other variable is likely to increase. A negative correlation means that the two variables go in opposite directions. So if one variable increases, then the other will likely decrease. A p-value can also be calculated for each individual correlation to determine if it is statistically significant. In general, a p-value of less than 0.05 is considered statistically significant. In this visualization, all correlations with a p-value greater than 0.05 are marked with a black X, indicating that they are not statistically significant. In this example, we are using R to determine if the two categorical variables, hospital death and sepsis, are highly related to one another. The data frame in this example is T, and the columns selected from this data frame are hospital death and sepsis. After running this code, we are given a chi-square value, the degrees of freedom, and a p-value. The higher the chi-square value, the larger the difference between the observed and expected outcomes for the variables being compared. The p-value, on the other hand, is used to determine if the results are statistically significant. One advantage of filter methods is that they are not likely to cause overfitting. However, since filter methods are only looking at the relationship between two variables at a time, they may cause you to exclude variables that have more complex relationships with the outcome variable. Also, when using filter methods, it is important to make sure that the predictor variables have low correlation to one another and high correlation with the outcome variable. Wrapper methods select variables based on their impact on model performance. Some examples of wrapper methods include forward selection, backward selection, and stepwise selection. Forward selection starts with no features and then adds them one at a time according to their impact on model performance. Once a feature is added, it is tried in combination with all of the other features one at a time, resulting in selection of the second feature. Then the third feature is selected by combining the first two selected features with the remaining features one at a time. This process continues until all of the features have been input into the model. Then the model can be refined to the optimal number of features based upon model performance. Backward selection starts with all the features and then removes them one at a time. The variable with the least impact on model performance is removed first. This process is continued until all the variables have been removed and then the optimal number of features is selected for the model according to the model performance. Stepwise selection is a combination of both forward and backward feature selection. Stepwise selection starts with 0 predictors and then adds one at a time based on model performance. However, stepwise selection also removes features if they lose their significance as more variables are added. Embedded methods automatically select features as part of the process of building a model. For this section, we will be using a random forest algorithm because it selects features for the decision trees that it creates to predict a specific outcome. This slide features an example of a decision tree that can be used to determine if it will be rainy or sunny today. In order to use this decision tree, start from the top and go down depending on the conditions of a specific day. Some machine learning algorithms build decision trees like the one featured above, automatically based on the data provided to them. A random forest algorithm is named as such because it is composed of many individual decision trees. Each of these trees will vote for a specific outcome, and the winning outcome will be selected as the final prediction of the model. In order for this model to work well, the trees must not be too similar to one another. To ensure that trees behave differently, each tree makes decisions based upon a random subset of features and random samples of the data. Thank you for listening today, and please work through the examples provided on the accompanying Jupyter Notebook for this section.